Welcome everyone to another observability clinic with another tips and tricks session today on workflows. And I have with me Igor. Igor, thank you so much for being here. Maybe a quick word of introduction from your side on who you are and what you do.
Yeah. Andy, thanks for having me here. I am a principal solutions engineer for the SOLA region in Dynatrace. I help on very specific customer use cases, and we have been using recently workflows a lot. So that's what we're going to be discussing today.
Perfect. And yeah, let's jump right into the topic because I think you've prepared a couple of tips and tricks, but also some introduction to workflows, some best practices. And yeah, Igor, please take it away. And folks, if you're watching this and if you want to learn more about workflows, also check out the description of the recording because I always put in some additional links to other additional material. But now, Igor, the floor is yours. Let us know what you have prepared for us.
Okay, thank you. So let's first start with some basic workflow. We're going to understand what are the basic settings, the test types, the trigger types, and everything involved, and how to glue these pieces together. And then we're going to do some advanced workflow, understand what we can do with JavaScript, how we can use the SDK, how we can loop through interactions and on the tasks. And finally, we're going to use a real use case. We're going to present a real use case from a Brazilian investment broker that we just used recently and was key to win this deal. Okay. Mm-hmm. So starting with basic workflow, what is a trigger? A trigger is what's going to start the workflow execution. Okay, so in Dynatrace, I can set up several different things that are going to start my workflow. I can start the workflow based on an event, can be a data's problem, can be a custom event, can be a business event. So that thing happens and the work triggers and have all the context about the event. So we can use the event values on the workflow to guide our execution. I can have a schedule, so we are not tied just to responding to Dave's problems or events. I can run a workflow periodically. I can specify a fixed time of the day. I can specify an interval. I can specify even a cron schedule, and also can be on demand. When I do on demand means the workflow will never execute unless I actually click on the workflow to execute, or I send an API call to execute this workflow. And this is very helpful because, for example, if I have a pipeline, I can do some stuff in my pipeline, and then my pipeline can make a call to Dynatrace, and Dynatrace will execute the workflow for us. So this is very good and very useful for automation. After we decide how we are going to start workflow, we have to decide what we're going to do. And what we do is divide in tasks. So I can glue several tasks together, and each task is going to be a simple execution that can be a dequal execution. So I want to query Grail for information. It can be an HTTP request to somewhere. I can make an HTTP request call to an API I have. I can make a webhook to a notification system I have internally. And also I can run a JavaScript code. So I can divide here. I have the trigger. This is an on-demand trigger, and then I can glue the tasks together and create flows on how the execution is going to happen. And also, my task can loop to an array of values. So I can feed my task with an array of values, and I'm going to do the same thing for each of the values there. So this can be a fixed array that I pass to my task on the UI. I can get the results from a previous task and use on the loop. Also, when we say about tasks, we have these 4 types of tasks. First, we have the dequal. We can execute a query against Grail. We have HTTP. We can make an HTTP call anywhere. We have JavaScript, and we have the custom. The custom is I can create my custom app, and this custom app can be a task that I use on my workflows. This is useful for very advanced users that I want to standardize some kind of action. So everybody in my company that's going to talk to my internal service desk is going to use a standard I created. I can create my own custom task. So we can see here on the screenshot, we have the Jira for workflows, we have the Davis for workflows. These are custom tasks created by Dynatrace, but the customer can also create those. This is not necessarily, everybody can live workflows without that, but very advanced users are going to benefit this. This is not the scope of this presentation, but it's nice to know how far we can go with the automation engine. And lastly, we can access the information on the workflows about previous executions, values that were returned using the Jinja expressions. So Jinja expression is not something created by Dynatrace, but it's something that we use to get information and format the payloads and everything we have on the workflows. We're going to see this on our demo later by the end of this presentation. And we also have some basic settings for the workflow. The most important here is the actor. We need to bear in mind that the actor right now is the user that created the workflow. This is the user that is going to run the workflow. And we can set up a service account. So the workflow is always going to run with the service account with the right permissions to execute everything it needs to do. So this is something that we do on the settings screen. And also I can put a brief description of my workflow, what it does, and with the owner and anything related to that workflow. And now we go to some advanced workflow where we're going to discuss how to use the SDK and JavaScript. So one thing that's very important is the loops. I have mentioned this previously, but this is really important, especially if I have a long running workflow that is going to deal with a bunch of data, several records. I can, instead of getting all the records and execute and manipulate all these records in a single execution, I can do a very small execution for each of the results I receive. So in this example, I have here a Jinja expression putting all the results from my depot query on an item variable, and then this item variable is going to be used by my loop. So every time I call this item variable, I have the current item on the loop. So I can, if I receive 1,000 rows, I can execute an action on each of the individual rows one by one. Okay, and I can define a concurrency. So I can, in this example, I'm running one by one, but if I change this to something else, I can do this in batches on the value I do here. So this is how many concurrent loop tasks I'm going to execute at the same time. I can access the loop value through the Jinja expressions, but for JavaScript SDK, this is going to be differently. So we are going to see how to do this on the JavaScript in a while. And loops are very important. On the use case I'm going to show, I was manipulating all the data at once and was reaching the limits of the workflow. When I started to loop, the task was much simpler to develop and would not reach the limits of the workflow on memory and execution time. And this is the concurrency we have defined, the amount of concurrent tasks we can use. And now talking about JavaScript tasks. JavaScript gives the ability for us to do whatever we want, code what we want. So imagine that the example we have here, I called the Grail to return some records. Then for each of the records, I had to call an internal API from the customer and then combining these results together. So I can do this using a JavaScript task. And the JavaScript, when we start, it creates a skeleton code for us, and then we can import internal Dynatrace libraries that we can use to access the APIs and everything. And then I can get my results and do whatever I want with the API. So this is very powerful on how far we can go with the information. And one important thing is that we cannot use Jinja expressions inside of the code. This is for security reasons. So we have a command that we get the current loop, add this to a variable inside our code, and then through that variable we can access the loop item. So we are going to show this on the use case later today. And some limits of the platform. So when we are dealing with our task, we have to know the limit of 256 megabytes per function executor. So if we have a code that is leaving things in memory that are bigger than 256 megabytes, the whole workflow is going to fail with an error telling you that. So we need to bear that in mind. We need to clean what we have in memory, or we can loop so we have smaller executions. And the result limit, when we send the result from a task to the next task, this has a limit of 1 megabyte. If we are doing this and bigger than this, we're going to receive an error telling that we are sending bulk data, and then we have to split this in smaller chunks so we don't reach the limits. And now the use case. So just a brief description. The customer here, this is Brazilian investment broker. They have this necessity. They have a logical organization of their applications in business units and macro groups. So they needed to have this in Dynatrace. Checking their process group, checking what they had, there was nothing in the process group that could tell me this is the business unit, this is the macro group. So I had to take this from an external API. So we agreed with the customer, they would tag all their process with the component ID. This is something they have internal, and that I could use a workflow to query their API and bring all the data I need to create this, to enrich what we have in Dynatrace. So at the end, we did this, customer tagged the process, we create the workflow. Workflow would get all component IDs that we had in the platform, query this API, and create a custom topology on top of Smartscape based on the customer organization. So this was very good because now they could see performance by their business units and macro groups. And this was a demand from the director of this company, and was key for us to win the deal. So we are going to see the workflow we use there, and then we are going to do a small thing together, just to show how we can accomplish a very complex use case like this.
Hey, Igor, I think, thank you so much. I kept quiet, but I wanted just to recap a little bit on what you've showed. First of all, thank you so much for the basic introduction to workflows. I think everyone that is just getting started, it's great to know workflows have a trigger, manual, automated, scheduled. Then we have the tasks, whether it's sending a web request, executing JavaScript, or querying DQL. People can also extend it with custom tasks, and they can also download or install, as we call it, apps that are available on the Dynatrace Hub. So some of the things you've shown with Jira, and we have the ownership information. We can call it Site Reliability Guardian. These are all things that you can download and install from the hub. And then I really like that you also showed some of these advanced capabilities with iterating, the looping, having access to all of the results from previous tasks. So folks, we will also link, as I said, in the description of the video to some of the additional documentation in case you want to learn more. But last thing here, this use case, what you have just on the screen, I think for me really shows the power, because you really said they have data in Dynatrace, right? For the processes, obviously we do our monitoring on a process level or on a container level, application level. And then you're pulling in data from external tools that have more, let's say, organizational data about these processes. And then you can combine it in a workflow and create new data out of it. And I think that's really powerful. So thank you so much. That's really good.
Yeah, this was really good. So let's jump to the demo. So I have here, just explain a little bit about the interface. When we get to the workflows, this icon here, this is the workflow apps in Dynatrace. So all the workflows I have access to will be presented here. So in this case, I have more workflows in this environment, but I have access to just these three. Those are the ones I have created. And this is the one that we are going to use for our demo. And this is the one we actually use from the customer. This is has no information from the customer, so we can share with everybody so people can understand how we did this. And this is the information we have. So this is on demand. On the customer, this is being run every hour. Here for demo purposes, I have this, left this on demand. So one important thing, every time I put an on-demand trigger here, Dynatrace also tells me how to access this and how to call this customer, how to activate this workflow. So I have the API call I have to run. I just need to add my token here to create the workflow, and then we are good to go. So if we want to run this on demand, I can click run here, or I can send the API call, and we are going to have this workflow executed. One other thing about this screen here, all these red boxes are the execution. So I can, on a glance, see if my workflows are running fine or not. So if they're green, the execution was fine. If they're red, the execution is not good. They are all red because I was testing this, but on a real customer, if you get here, it's red, something will happen and we have to fix our workflow. So it's really nice to see if everything is healthy or not. So when we get to our workflow, and this is the real customer example, I had to deal with authentication. They have several APIs. They sent me the client ID, client secrets. I added these to the vault on Dynatrace. And to get this information from the vault, I have to use a JavaScript task. So this JavaScript task is just creating the credentials. And then at the end, I'm using the credential vault client. And then I can have everything, and I return a credentials object, that I can use throughout my workflow. So every time I need to authenticate an API, I have the right credentials here. I don't need to show client IDs and call it secret to anybody. This is kept safe on the Dynatrace Vault. And then I have my workflow. This generate macro functional group was just something that we had to do because the customer didn't have all the information on the API. It's just a simple JavaScript that returns fixed values. But the important stuff here is this get tag process groups. Here I have a DQL query. Querying Grail is searching for all the process groups that have component ID and is returning me. So this returns me what I need. And then on the following task, I have my API call to get the information I need. So here I have the API. This is an internal API. In this case, the API was not open to the internet, so we were using Edge Connect. I'll show you what Edge Connect is in a while. And then I can have my Jinja expressions. Let's just open this. Everything that's between these two curly braces here is the Jinja expression. So here I have a variable that's coming from the Jinja expression. And this underline dot process groups component ID, this is the result from the previous task. This is a loop task. So if you can see here, I have a loop task, I have my process group variable, and the result from the previous task is being filled to this process group. So when I get here, I have process group is my variable and component ID is on the result. So I can see what's coming on, and then I can feed this to the next task. And then for each of the results, I'm going to make an API call. And as we can see here, I have the authorization, I have my barrier token, and I have no access to the token itself. So the execution is quite safe. We don't have to worry about people finding our tokens and misusing this. The next task, in this customer, they have two APIs. So I have to call one API for one part of the information and a second API for the second part of the information. This is the same stuff. I just change the variables here because this is a result for this component screen. And then I have the generate event content. This is the task that does everything. This task combines all the results and then sends all these results to the metrics. So create metrics to Dynatrace, and these metrics are just populated in the platform, and based on these metrics, the topology is created. Okay, so this task here is also looping. So I have a loop task here. This is looping from the last component, and then I have my JavaScript the conditions to get all the other results and combine them together. Wait 1 second.
All good. I think all good, Igor. I think we can also share the code later on. Not sure why it's not loading right now, but it's also good. But really impressive. Really impressive that you can chain together these processes and these workflows, and you can access the results from previously. I really like your best practice that you are initially getting the token from the vault, so that all the other functions or all the other tasks have this available. So this is really great.
Yeah, and this was a requirement from the customer because we couldn't have these tokens flying everywhere. So having the ability to access this safely on the workflow is very, very, very good for us. So let's go to the simple workflow I have here. So I can see here this is also a manually triggered workflow, and here I have a simple DQL query that we're going to show. In this DQL query, I don't have actual data, so I'm just creating 5-6 records of mock data, and then I'm feeding this to the next tasks. So when I hit run here, this is going to execute the DQL query, and then proceed to executing the HTTP requests. And then everything is good with my workflow. And if I get to my task here, the DQL query, if I go to this tab result, I can see all the results. So this is the information I'm going to use to access the data on the following task. So I can see that this task is returning a types record, a records record, and a metadata record. So on my next task, I can see that records is what I need to do. the records, I have an array of information, and this is the result of my DQL query. So if I need the component ID as I'm using on my workflow, I just need to access these records and each of the array values on the component ID variable. So when we get to my following task, the HTTP request, let me edit my workflow and see how the HTTP is being run. And this is important. I'm using the Edge Connect to call my internal API. I'll explain the Edge Connect later. But first thing is going to options and see how I'm using the loop. So I'm getting the results of my DQL query. So I have this Jinja expression getting the results of the previous query, and then I put dot records because that is where I have my information. If I just leave without the records, I'll get all the information I need, and this is not the actual value, it's all the metadata and the return from Grail. So to get the actual data, I need to put this dot records. So I had the array of records now fed to the item variable, and now I can get back to my code and I can access this. How do I access this? Item component ID. If we look here, we have a hint on how to use my item variable. So using this curly braces underline dot item is the way to access this item variable on my task. And then I just need to know that I have the component ID on the array, and then dot component ID, I receive the information. So this means that I am now, for each of the results of my executed query, make an HTTP call to this component API, and this is returning me a JSON, okay? If I go back, and now if I want to see my execution, I can click on executions. It's going to show my execution list. From 2 minutes ago, I have my execution, and I can see the results of my task. So the HTTP request task 1, I can see the result, and now I can see that for each of the DQL queries, I made an HTTP request, and this is the result. I am being returned the JSON from that API, and now I have all the information I need. On the customer environment, I have the application services, the business services, the price services that component belonged to, and that I would use to create the custom topology. Here on my example, I'm just returning some mock data so we can see how the return from the API would work. Okay, and now I do the same thing for the next step. So on my second task, I have again a loop variable. So I have a loop variable that I'm using the result from HTTP1. I'm doing the same thing. I'm doing the Jinja expression to get the result from the previous task. I'm using this in this way in my code, and then I can change the concurrency. So if I change this to 10, this is going to be more concurrent. As this is a very small workflow, this won't change much. But for my actual use case, when I add 10 concurrency on the concurrency value, it would increase the speed, and the workflow would be half faster as it was before. So it's really good to bear in mind that the concurrency can play a huge role on speeding up the performance of our workflow. And then I make the call and I receive the information. This is an internal API. I don't have any headers. So if I go back to my executions, I won't save my workflow. And then if I get to the HTTP request 2, I can see the results from my API. This is a different results. It's very similar because the API are most the same, but I have the results from my second API, and I can loop through that. And then I have my JavaScript task. And one important thing here is that this task is in gray because I have disabled this task. Okay, it was failing, so I have disabled. So if I'm working with workflows and I have a task that is not running because I still not finished, I still have some debugging to do, I can just disable that task and the workflow will keep running, and that task is not going to be executed. So here I have my JavaScript task. If I click on these dots, I can re-enable enable my task, and then it's going to be able to run. And if I don't want to run, I just reach disable task, and it's going to be here. One other thing, we can name our task whatever I want. When I create JavaScript task, it's going to be JavaScript 1. If I want to change something else, generate custom topology. Okay, we cannot use spaces. If you use spaces, it replaces automatically by underscores. Okay, so now we have our JavaScript task, and I want to show you this how we access the information on the code. If we get to my options here, I am using again the result. So I'm getting the results from the previous task. In fact, I'm getting the results from the execute equal query one and feeding this to the item variable. But I cannot use this on my code. As for security reasons, we are not allowed to use Jinja expressions inside JavaScript. So the way to use this on the JavaScript is through this command here. So we have this this command is a standard command from the workflow SDK, and then I get the current execution, and then I can get the current loop item. So I just have the loop item, and then I can get the value from the loop item, and I'm going to be able to use throughout my code. So this is the way we can use this snippet of code every time we want to access a loopy item inside of our code. After we do this, the result variable is going to hold the current loop and can use for whatever we want. One other thing that is important is when we create the JavaScript task, is going to create a skeleton code for us, but not everything we need is going to be there. Most importantly, adding these imports. Always we're going to have the simple imports that we need to use for a basic execution task. But in my case, I was sending events and sending metrics to the Dynatrace API. So I had to import these two SDKs here to be able to send events and send metrics. Once I have this imported, I can send metrics and send events using Dynatrace SDK. We have documentation for that, and I need to get from the results from the other tests because this was a very complex situation. I have 4 tests that combined, I would have the results I needed. So I had to create this code here just to get the previous tasks information. So I had 1 task coming from the loop item and the other 3 tasks coming from this code. So what I'm doing here, I'm creating a local variable, and then I'm using the executions client to get the task result. And this is very simple. We just need to feed here the execution, the task name, and we're going to have these results. Okay, so what I'm doing here and why I have this promise here is because in my case, the amount of data that would be come from this task would be very, very big. So this would take a while to fill the variable. So instead of doing one by one after the other, I just create a promises array here. I do everything in parallel, and then I wait for all the promises to finish. So I'm sure that I'm getting all the values in parallel, and then after that, I can use this on my code. So this is, once I have this finished, then I can execute this code. And then I'm going to have this result target PS. I'll have the value of the task, the other task, and the other task, and then I can use this on my code. So this is very nice. Not all the customers are going to need to go this far on JavaScript code, but this is nice to understand how far we can go and how complex things can be and how powerful workflows are. And at the end, we can manipulate the task, and then we can execute. So I'm going to run this this task, this workflow. And one important thing is that when we get to this loop tasks, while the task is running, we can check the results, and they are going to appear here. We don't need to wait for the task to finish. If I have to look through 1,000 items and halfway through, I want to see if the results are coming fine, I just click on the results, and they are going to be fitting here. I'm going to see the results popping in, and the ones that are not yet executed won't be here. So now I have everything. As my task was disabled, it didn't execute. So I'm going to re-enable it. Let's save and run again.
So Igor, while this is running, just to recap again, also some of the best practices. First of all, naming is also very important. I know you went here with the execute DQL query 1, but it's always good to also think about proper naming, because that name will later on be used to access the results of that particular task. And so then this is why a good practice could be make sure that you are giving good names. I think that's good. And then the other thing that I wanted to say, it's really cool what you show here. You're querying data from Dynatrace, then you're executing, you're pulling in additional data from an external API, and then have JavaScript that kind of does some calculation around the whole thing, and then whatever you want to do with it, log it out, create a new metric, create a biz event, whatever makes sense here.
And the things that we can do is enormous. For example, we have a situation where a current customer in Brazil, they have some events that come through logs, and one of those events happen, they have to check a previous event and calculate the amount of time between the two. And then we could just keep running SQL queries in sequence and combining everything. But now we create a workflow that is going to be triggered when the event happens, and then it's going to trigger the previous task, the look for the previous event, and then create a metric and post to Dynatrace. So the customer now, they have the ability to use SQL, post a metric, and they'll have the metric, so they don't need to have all these events for all the time. So the amount of possibilities we have now with workflow is very, very big.
Cool. And it seems now, sometimes you have a JavaScript error as well, then you also get the error details,
Yeah, if something fails on my JavaScript, it's going to tell me where it happens, what's the line. I think I have some syntax problems on my JavaScript on line 36. Yeah, some curly braces not working, but this is not important. What is important is that when I'm working with JavaScript, everything I do here is going to be shown. So let me just comment this code so we can have the JavaScript working fine. I'll comment the process also, and we're just going to return a simple variable so we can see how we can return something from the JavaScript and use in the following task. So I'm console logging something, and then I'll return something as my JavaScript result. So this is what we can do to return value. So everything I put on return on my function here is going to be appear on the results of my JavaScript execution, and I can use this on the following task. So now my task is going to run again.
And then also, while you're talking about this, you also have one thing that we didn't cover is the conditional execution. You can also on a task not only specify how to iterate through the results of a previous task, but you can also say this specify condition where you can say execute this if the previous task is returning a certain type of value. So then you can also branch off. It's really powerful.
Yeah, that's right. I'll show you in a minute how to do that. So now let me just show the execution we did. So now if I get to the generate custom topology, I can see on the result is returning something because this is the value I'm returning. So everything I return on my code is going to be here. And now I have something being logged because for each of the executions, I'll have something being logged. And when I have JavaScript looping, each of the executions is going to be split by this line. So I can see that this is each of the interactions I did with my loop. Okay. And if I want to do some conditional execution, I have this conditions tab where I can say what's going to happen. Let's see if I call an API, and depending on the result of the API, I need to call a different API. I can say here what's the condition. So in this case, this one is running because this one was success or skipped. So if I want to execute this just if the previous task had an error, so this is going to be if errors out, then I'm going to execute this. If this doesn't error out, this is not going to be executed. So I can control the flow here and do whatever I want. Also, on the Jinja expressions, when I'm using Jinja expressions, this is a get, but if it was a post, I can use Jinja expressions here and use a for loop in the Jinja expression to create my payload. So imagine I receive a bunch of records and now I need to format this as a JSON. I can use the Jinja expressions to conditionally format this, and I can use ifs inside the Jinja expression. So we have documentation for this on our standard documentation that people can use. I have used it sometimes to format my payloads.
Wow.
Okay, so this was everything I had to show for you guys. I hoped I was able to introduce and help you understand how workflows can be used and how powerful workflows are.
That is amazing. Igor, thank you so much. I love that. So I've been starting to use workflows myself quite a bit. I really love the Jinja expressions. I did not know yet how to easily access this in JavaScript, so that was good news for me. I learned something new. Also, just like showing people that the real life use case was really great. So folks, Dynatrace workflows are really best to orchestrate tasks around data that you already have in Dynatrace. So like in your use case, you have data from your processes in Dynatrace, but then you enrich the data with external data, and then you create something new out of it or send a message. What we typically see is sending reports back to Slack, creating tickets in tools like Jira. That would be an option, or just create additional new data because you are pulling in data, aggregating it, and then creating a new biz event, and then you can report on that as well. So
Yeah, that's right.
Igor, I'm pretty sure you have more workflows and workflow stories coming up in the future. So I would love to have you back on more of these sessions, because I think this is really a great way to see what's possible and then also learn on how to apply this in your environments. Yeah.
Yeah. I'll be glad to be back.
Yeah. Thank you so much. All right. With
Thank
this,
you.
everybody, bye-bye. See you next time.
See you. Bye-bye.